There are several UFO videos that were shot with thermal cameras that look like they are showing infrared glare. I've described this as what would happen if you looked up the tailpipe of a jet engine, and I've often illustrated it by pointing a flashlight at the camera to show how the glare, the spillover light or radiation, obscures the flashlight. The flashlight analogy raises questions, specifically to do with the angle between the jet exhaust and the camera. Why do we still see a large glare when the exhaust isn't pointing directly at us? And why doesn't the glare get smaller as the angle increases? In the Chilean Navy case, we've tracked down the actual plane and its exact track, and we know for sure we're looking at 4 large jet engines on an A340. The large area around them is glare. The glare is quite large. If we stick an F-18, which has 2 hotter engines, in the locations of one of the A340 engines, then we see the glare is much larger than the small jet. But with the Chilean case, we first see massive thermal glares around the engines of the A340 when it's 25 degrees from the camera and 40 miles away. And then, as the tail angle rapidly decreases so the engine is pointing directly at us, we don't see the glare get any bigger. Why is that? In the case of the gimbal UFO, the black shape looks like a rotating infrared glare, possibly obscuring a distant jet engine pointing its tail at the camera. But people who disagree point out that in 3D reconstructions, the angle between the exhaust and the camera is quite large and varies a bit, but we don't see a correlating change in the glare size. The problem here is that a jet engine's heat output isn't really like a flashlight. A flashlight has a directional beam because the light is collimated, i.e. it's collected and directed in a particular direction. Older flashlights with bulbs use a parabolic mirror with the bulb at the focal point. Newer LED flashlights use a lens. The end result is the same. The light from the flashlight is narrowly focused in one direction. You see this here when I tilt the flashlight down. There's a narrow central bright beam. Pointing this beam at a camera results in a big glare that nearly covers the whole image. But all I have to do is rotate the flashlight 5 degrees and the size of the glare is vastly reduced. But jet engines don't have a lens or a parabolic mirror. The back end of a jet engine is essentially just a tube, and a short way down that tube is the red hot metal of the jet turbine. You can see that hot metal from a fairly wide range of angles. We can simulate this with our flashlight by removing the lens. Now we've just got a tube, and we see that the light spreads out evenly in a cone with no central beam. If we point this at our camera, we still get a large glare. This is smaller than before, but still a lot bigger than the flashlight. The big difference now is that when we rotate the flashlight, our simulated jet engine, the size of the glare remains constant for about 30 degrees, and only then it drops to almost nothing in just a few more degrees. So this explains how we can have a glare size in gimbal that starts out large, 25 degrees, and does not change much with decreasing tail angle. It also matches the Chilean video, where the glare is first noticed at around 30 degrees, and stays about the same all the way down to about 3 degrees. It also helps explain the tic-tac as a distant jet. At the start of the video, the tail angle of the object is around 20 degrees. And in the infrared, we see only a large glare obscuring the jet. Then the tail angle increases to 40 degrees, and the glare is greatly reduced. You can see it on the right here, and the rest of the image is the shape of the jet, or the flying saucer. We also see this in other videos of planes that are flying away and then banking to the side. The glare is constant for a while, then shrinks and vanishes. So, in summary, we'd expect to see constant glare for a wide range of tail angles, so the fact that it starts large and does not vary much in gimbal is consistent with the distant jet hypothesis, and the similar behavior is consistent with the same hypothesis for the tic-tac video.